So here we want to find the 6 trigonometric values if we're given the cosine is equal to 8 over 17. Well, we know the cosine. We would then obviously know its reciprocal. The reciprocal of cosine is secant. But what do we do for the other ones? Well, we know cosine's adjacent over hypotenuse, so you could go ahead and draw yourself a right triangle, knowing that your adjacent side would be 8, your hypotenuse would be the 17. So here's our adjacent, here's our hypotenuse. Well, knowing two sides, we could use our Pythagorean theorem to find our missing side. We could go 8 squared plus a squared equals our hypotenuse squared. And so then we get the square root of 225, which is 15, so we would get this. Then we could just go ahead and draw or use SOHCAHTOA or our definition. It would not make a difference. If we did opposite of 15 over hypotenuse, we would get this. Then we could do its reciprocal, which is cosecant, so we'd have to just flip that upside down. Then we could use SOHCAHTOA and go tangent, which is our opposite over our adjacent, so 15 over 8. And then our cotangent would be the reciprocal. So a lot of times I would encourage you to draw this out. Draw a triangle. If you draw the triangle, you can probably see how to do this. Now here, whenever you see a word approximate, a good idea to approximate is to use your calculator. So you'd want to hit the mode button on your calculator, hit mode, make sure it's in degrees because you're dealing with angles in degrees. Then you just type in cosine 77, hit enter, and you should get this. If you don't, talk to me in class and we'll try to figure out what's going on with your calculator. Now on your calculator, you don't have a secant button. But remember, secant is 1 over cosine. So we could type in 1 over cosine 202 degrees, and then we would get this. Similarly, you do not have a cotangent button on your calculator, but you do have a tangent, and we know that cotangent 1 over tangent. So we'll type in 1 over tangent negative 81 degrees, and we would get this. So if it says to approximate, more than likely the best way to do that is going to be using your calculator. And if you don't have a calculator, you better find one that you can borrow or buy. Now, down here we need to simplify this. We have some squareds on our trig functions. A lot of times when you have squareds on your trig functions, you can use your Pythagorean theorem identities to help you out. Notice on this one here, we have a 3 times our cotangent and a 3 times our cosecant. So we could pull that 3 out. Then you got to think about which Pythagorean theorem identity would help us. Well, that's a 1 plus a cotangent squared alpha is equal to a cosecant squared alpha. Now, ours is not exactly like that, but if I subtracted a cotangent squared alpha from both sides, you see I get exactly what we're dealing with of a cosecant squared alpha minus a cotangent squared alpha. So this whole thing right here, I could simplify down to 1, and 1 times 3 is still just 3. We also need to simplify here. We don't really have a lot of squared, so I'm not sure if Pythagorean theorem identities will help us or not, but it might. But we do have one big fraction bar. So let's work with what's above the fraction. We know that cosecant would be 1 over sine. And then I have 1. So sometimes when you're working these out, it's going to be simplest to turn everything into sines and cosines. And so that's the approach I'm going to use here. Well, this first fraction here in the bottom is already in sines, but this one here is a cosecant, which once again means 1 over sine. Well, now on top, all I'm doing is just adding fractions. Remember, to add fractions, you have to have a common denominator, which would be sine. So remember, this is 1 over 1. You'd have to multiply top and bottom both by sine over sine, so we get this on top. On the bottom, your common denominator would be sine squared. We already have that here. We'd have to multiply the second fraction, top and bottom, both by sine to get our common denominator, so we get this. So now we could write the top as one fraction, 1 plus sine, over our denominator. And we could write the bottom as one fraction, 1 plus sine over our denominator. So it'd be 1 plus sine over our denominator squared. So now we have a fraction divided by a fraction. So instead of dividing by a fraction, I can multiply by the reciprocal. When you do that, you always take the top fraction, multiply it by the reciprocal of the bottom one. Now you can see that we have a 1 plus sine top and bottom. And then we have a sine squared over sine. Well, which one has more sines? The top does, 1, so it's going to just simplify down to a sine. So here you're asked to rewrite tangent in terms of cosines. Well, you know that tangent is sine over cosine. So that means we're halfway there. The problem's now in two parts. Half of it's in cosine. So now we got to think about how can we relate sine to cosine? Well, that's our main Pythagorean theorem identity. Sine squared plus cosine squared equals 1. So we want to go ahead and solve it for sine. To get sine by itself, we'd taken that cosine squared to the other side by subtracting it. And then we'd have to get rid of the squaring, so we'd take the square root of both sides. So in other words, I can put the whole bottom as cosine, but instead of writing the top as sine, I'm going to replace it with what sine is, and that's that root. And so now I would have tangent written only in cosines and normal numbers. So here we want to verify these identities. When you're verifying an identity, you can only work with one side. You cannot treat this as an equation and do stuff to both sides. You start with one side and you continue to work with that one side until it ends up looking like the other side. Now, this one here specifies start with the left side until it looks like the right side. And that's what I'm going to be doing. But technically, if you're doing any identity, you can start with either side. Typically, I would start with the side that either has more stuff in the denominator or more terms. Even if this did not specify to start with the left side, I would probably start with the left side because I really have two terms or two different fractions here. I find it easier to add two fractions together to get one fraction than it would be to take one fraction and somehow break it apart into two. So what I'm going to do is to rewrite this cotangent is cosine over sine. Tangent is sine over cosine. So choosing to rewrite it in terms of sines and cosines. Now I'm not going to use any identities right now because I don't have anything that's being squared. So now I have to do a common denominator, which is sine times cosine. So my first fraction, I need to multiply top and bottom both by cosine over cosine, which is a special form of 1. And remember, multiplying by 1 doesn't change it, the value, only the appearance. The second fraction needs a sine top and bottom until we get this. So now I have my common denominator. I could write it as one big fraction. Cosine times cosine is cosine squared, plus sine times sine is sine squared over my common denominator. Oh! Looky here! We have some squareds. And it's an identity that you're supposed to have memorized. Sine squared plus cosine squared is 1. So that's simplified a lot nicer. So now this is really a 1 over a sine times a 1 over a cosine. Well, 1 over sine, you know, is your cosecant, and 1 over cosine is secant. So once I would have got to here, I maybe would not have been aware of what I would do next. But that's where you want to keep an eye on where you want to end up with. We're not working with this side, but you're keeping an eye on where you want to end up with. We had a 1 over sine and a 1 over cosine, and we knew we wanted to end up with reciprocals of sine and cosine over here. So that let me think, let's write it as separate fractions so I can get to those reciprocals. On the right one over here, right problem, I would still start with the left-hand side. I would probably go ahead and distribute my tangent through. Tangent times tangent would be tangent squared. Tangent times cotangent. These are reciprocals, and remember, when you multiply reciprocals together, you just get 1. Oh, now this is a squared, so a Pythagorean theorem identity should help us. And oh, a tangent squared plus a if I can talk, sorry, a tangent squared plus 1 is our secant squared from our Pythagorean theorem identities. So here we need to find our 6 trigonometric values. So first of all, I'm going to draw myself a triangle. Now, cosine is 1/2. Cosine, according to our definition, deals with x. So we have cosine equaling positive 1/2, so that means our x-coordinate is positive. So if you're thinking of your 4 quadrants on your xy axes, that means if x is positive, you'd have to either be in the first quadrant or the 4th quadrant. But you're also dealing with sine. Sine deals with y. And you're told that sine is negative, meaning less than 0. So that means your y value is negative. So in quadrants 1 and 4, we know we're going to have to draw a triangle in the 4th quadrant because sine is negative. And that's your y value. So y is negative and x is positive. So we'll draw an angle in the 4th quadrant. So we'll draw our xy axes, draw an angle into your 4th quadrant, and then you always make a right triangle to the x-axis, always to the x-axis. So if we do that, we get this. Now, your angle is always in your triangle at the origin. We know that cosine is either x over r, so 1 here and 2 here, or thinking of SOHCAHTOA, it would be adjacent to your angle over your hypotenuse, which would be 1 over 2. Now you want to go ahead and do the Pythagorean theorem to find your missing side. So we could go 1 squared plus y squared is equal to r squared. So we get 1 plus y squared is equal to 4. Square root of, or y squared is equal to 3. So we get y to be plus or minus 3. Now, because we're on our coordinate system, we have to decide, based on our picture, is it positive root 3 or is it negative root 3? Because we're going down, we know it's negative. So now we just have to do our SOHCAHTOA stuff. Sine is opposite over hypotenuse, or y over r. Doesn't make a difference. Cosecant, then you just have to flip that upside down, and then you'd have to rationalize it. We were given our cosine of 1/2, and we can see if we go to our triangle, we would get 1 over 2. Secant, then you just have to flip that upside down. Tangent, you could either go y over x or opposite over adjacent, and you would get negative root 3. Cotangent, then you just have to flip it upside down. So it'd be 1 over negative root 3, and then you got to get that root out of the bottom.